Decentralization Media.
Hi guys, I'm Mr. M. In this video, we are going to look about proof of work. Proof of work was a scenario that will be reduce the DDoS attacks. So that is the main purpose of proof of work that when it's invented. And as I mentioned, as a DDoS attack, it means like it will be sent to one of the computers or else one of the servers multiple fake requests to reduce the computation power or the processing power that that machine has or the server has. So then once you are producing multiple fake requests, so it will be overloaded with the request and it cannot produce the outputs for those requests and it will be failed. Those endpoints will be failed. So that is the main cause of the DDoS attack, and proof of work is one of the scenario that will be reduce this DDoS attack. So that is one of the main purpose of proof of work. So it's not a new topic in the world. So ideally, Sindik Dweck and Moin Nair was invented this one in 1993, and it was like named as ideally coined as a proof of work as a name in 1993 by a paper published by Marcus Jacobson and Ari Jules. But it was got famous all over the world when Satoshi Nakamoto was used this one in 2008 to reduce the DDoS attacks in the Bitcoin network scenario, as well as it will be used to do the genuine job that when the miners are doing mining process as well as when they are doing a validation process. So let's see how this proof of work works. When you have a miner as a Bob who is doing this mining process, then mostly in Bitcoin network as well as a couple of other famous blockchains will be use this proof of work as an algorithm to do the mining process. So when Bob was selected as a miner, he'll be initially get a hash that is including all the previous block, current block, root hash as well as timestamp and various different details. So you can see more about this how this mining process happens in the previous video that we published about how mining works and how Bitcoin, especially how Bitcoin doing the mining process. And here I'm just overlooking how this proof of work algorithm will be used in this mining. So not much more about the mining process. So you can have a look on that video as well. So once they get this hash, they will be get a nonce as well. So this is the nonce that will be they do repeatedly to upgrade these nonce to match with the next block hash, and they will be get expected output as like it has a difficulty rates in the blockchain network. So initially it was created with couple of zeros in those days, and when the computation powers or when people are using much fast and advanced computation machines to do this mining process, then the difficulty will be reduced because people can quickly find out this nonce and they can easily do this mining so fast. So then that will be sometimes will cause a DDoS errors as well. So for that, each time when the Bitcoin network itself, each time when the difficulty rate is going reduced, so it will be added another zero as well. So likewise, it's added the zeros, and currently we have around 19 zeros in the network. And every new miners knows that okay, for the next block they need to have a hash that is leading with 19 zeros. So once they get these two inputs, they knows that they can't go and make any changes in the hash. So the only point that they can make a change in the nonce. So what they'll be doing is they'll be append these two strings into another new string, and then they'll be hash that string. So mostly in the Bitcoin network they use the SHA-256 hashing mechanism. So once they do a hashing, then they'll be compare this actual output with the expected output. So if it is not matching, then they can only change these nonce, because the hash values contain all the other important relevant data that need to be goes inside the block. So they can only change these nonce. So they will be upgrade these nonce each time until they get the expected output that's leading with 19 zeros. So once they find this output, then that is the endpoint of the mining, and then they will be create this next block with this hash as a fingerprint, and they will be distributed with the other nodes. So why they are doing this block proof of work algorithm comes into play here is the hash that they are creating, that is including the root hash as well. So the root hash is the hash that including all the transactions that are validated by the miners. So once these miners are doing some malicious work and try to do something and upgrading or updating some transitions, then what happens is the mining process will be, if it is not difficult, then it will be very easy for the people to manipulate the network. So as it's more computation powers and it takes so much of time as these difficulties and all comes into play, so it's take around like a in Bitcoin scenario, it takes sometimes 30 minutes, sometimes 15 minutes. So mostly it's take around 10 minutes to create this next block. So it has a time period that you need to prove your work. So ideally, you need to do a good job on validation the transactions, but you need to prove that actually you did this job. So by doing this proof, what you are doing actually is you are wasting your computation power. So as you are wasting your computation power, that means actually you are wasting your electricity, and that is equal to a money that we are spending for the electricity. So even if you are doing a malicious job, or else if you are trying to manipulate the network, then that means you are wasting your energy, but you are not going to get anything as a rewards. Because once you're doing a correct job, only miners will be get mine and create an X block, and those miners will be get the mining rewards as well. So if you are doing a manipulating a network, or else if you are doing something malicious works in the network, then ideally you are wasting your computation power, but you are not getting anything as a rewards. So why we need proof of work again? So the two reason is like one is to validate and create the new block, as well as reach the consensus. So the validate and create the new block. So as there's no central party in the blockchain scenario, so whenever there's a transaction comes, some blockchains will be use a time period like 10 minutes. So each and every 10 minutes they will create a new block. Some blockchains will be reach a transaction count. So after like 200 or 300 transactions, or sometimes 2000 3000 transactions, once they reach, they will be create a new block. So as to create a new block, you need to select a person to create a new block, as it's a decentralized mechanism, so anyone can create the next block. So for that we need a proof of work kind of a scenario where multiple people are participating, but we need to maintain that trust on that system. So if you have a proof of work kind of a scenario where you need to waste your computation power to prove that you did a genuine job, so that through that way you can earn the mining rewards. So that is one of the reasons that we are using a proof of work algorithm in the mining process. And the second one is to reach the consensus. So one for that we need to have a proof of work scenario, so we can tell it to other peers or other nodes that okay, we did this mining process and we find out this node, find out this block, and this is how we did the proof of work. So this is the nodes that we found out, and this is the difficulty time. So we did a genuine job to create this next block. So they can also accept this as a valid block, and they can add it with their chains. So proof of work has two advantages. So one is mainly DDoS attack, as I mentioned. So it will be stop the DDoS attacks to happens, because we need to have wait for 10 minutes, and even multiple people are trying to do it. Then it will be take the same time for each and every nodes. Even if you have a supercomputer, still that difficulty period will be increased. Even if your supercomputer powers are increasing and you are mining it so fast, so the network itself it will be increase the difficulty time, and that will be reduce the DDoS attacks. And the second one is it's about computation power over the wealth. So even if you have so much of money, or even if you have multiple bitcoins or even millions of bitcoins, still you can't go and create an X block in the Bitcoin network or in any other blockchains, because it's always whatever the mining process that are using proof of work algorithm will be always support for the power over the wealth. So even if you have a high supercomputation power over, and if you have a less amount of money, still you can do the mining process than comparing a person who has more money and less computation power. And the other ways is like even if you have a supercomputers, or even whatever the high-end machines that you're using to do this mining, still the difficulty times will be increased if the mining difficulty period is getting reduced. So whatever the power high-end machines that you're using, you can't do the mining always as same as the power that you're using now. So in the times goes, it will be change, and the process will be very harder in the future as well, because the difficulty will be get high. As it has more advantages, it has disadvantages as well. So one of the major disadvantages is consuming so much of electricity. As in the map that we marked in the yellow, those are the yellow orange, so those are the countries that are consuming more electricity than the Bitcoin mining itself. So even the proof of work algorithm is used by Ethereum and a couple of other famous blockchains as well. So this map is only showing about Bitcoin mining, and those are the countries marked in the orange or yellow that are consuming more electricity, that are consuming less electricity than the electricity that they were using for Bitcoin mining. So this is one of the disadvantage, because it has a process where multiple people can participate, and it's like a game scenario. So anyone can come, as is a decentralized scenario, decentralized system. Anyone can come into the play, and anyone can do the mining, and who is doing it first will get the rewards. So for that, mining rewards currently is as 12.2, 12.5 bitcoins, and after these May 2020 halving, it will becomes to 6.25. So it's still a lot of money. So multiple people, multiple mining pools will be trying to do this process to gain these mining rewards. So for that, everyone are wasting so much of electricity energy. So if there's a one person doing this one, then it will be reduce the electricity power. But as it's a trusted mechanism, and it is most as it's the most trustable mechanism as a proof of work where multiple people can participate it and there's no central party to control it. So this is one of the trusted way and most secure way that we can do this mining process and create this next block. So that is one of the disadvantage. And the second one is 51% attack. So in those days when Bitcoin was created in 2009, 2010, even 2013, we can use our normal machines to do this mining process and we can earn these mining rewards as by creating next block. But nowadays it's very difficult because there are more it's more commercialized and a lot of the mining pools were created. So mining pools basically, so this also we mentioned in our mining video, so you can go and have a look on that. But I'll give you an overall example. So mining pools are mainly, there won't be any single miners will be there, but there will be a mining specialized mining chips, and those ASIC chips will be planted in a huge area like a data warehouse. There are multiple like hundred thousands of chips will be there, and those will be do this mining process. So it's very difficult for a single machine to compete with those mining pools. But the disadvantage here is like as we have most of the mining pools are mainly based in China, and this map is showing only about Bitcoin mining pools. So if we take about like Antpool, BTC Top, BTC.com, and Big so those are the main main four pools, and if we take all of those four pools, we can see like it has more than 51% of the control in the network. So in a scenario that if all these four pools comes together and have an agreement that okay, they are going to control this Bitcoin network, so it's not possible because all these can come together and they can make a next block, and they can add or they can remove or they can update any transaction that is going inside because they have the computation power, and all of these has a 51% of the power. So then the next blocks also will be created added to that previous block, and they will be made in the longest chain. But the problem is like as it's a decentralized scenario, so even if a person or even if all these pools comes together and create a next block by manipulating the network, so everyone can know this one. So what happens is people will be create a fork and they'll be moved towards another chain without depending on this network or this chain. As well as it's a disadvantage for them because by doing this scenario they are not going to earn any rewards because as they are wasting some of the computation power, that is one of the thing. But the thing is they have invested so much of money to create these Bitcoin pools. So if they're doing one of the simple mistakes like this, then no one going to be use these Bitcoin scenarios, or is even no one going to be use that fork. So then what happens is it will be a fail for them as well because their investments and everything will be goes overnight. And even some of the scenarios like some of the mining pools have got more than 50% of the powers, but still they didn't do anything because they knows that if they done something everyone are watching on them. So it's not a centralized process. Even if it is a centralized process, it's very easy because some people can do it and others can't see what happens there. But in a decentralized mechanism everyone can watch those things what happens, and it's very difficult for them to do it, as well as it's not a benefit for them as well. So thank you guys for watching this proof of work video. Leave your comments in the comment section, and do subscribe our videos and click the bell icons for future notifications. Thank you.
Decentralization Media.